Okay, so how is everyone today? Good, I hope. I need another break to get over the break. Okay, so first thing, it's come to my attention that something happened to WebAssign. I'm not exactly sure what, but it sounds like I might have typed the due time as 11:59 a.m. when it should have been 11:59 p.m. Okay, so we'll just extend that to be due probably Tuesday night, so you've got plenty of time to deal with that. Sorry for the anxiety that might have caused you if you happen to have waited until yesterday. Good. Midterm exams should be graded by Wednesday afternoon. Any questions about logistic matters before we get to business? Okay. So there's been a break, spring break, since the last time we saw each other. So let's remember all the things that we talked about last time. So, first is that if you plot the graph of the equation y equal x squared, then you get a shape that looks like this. And this shape is common enough in human experience to have a name. What's its name? Parabola. So in fact, it is true that the plot of any y equal to ax squared plus bx plus c with a non-zero a, the plot of any such equation is a parabola. But parabola. For various different a's, b's, and c's, those have the effect of moving the parabola around and turning it upside down and things like that. For now, the only distinction that we're making is that some parabolas are going to end up looking like this. So it's like we took this parabola right here and we sort of turned it upside down. What must be true algebraically in order for this to happen?
Some negative coefficient.
Yeah, a has to be negative, the leading coefficient. And I always draw it like that so it looks like a frowny face, because negative people are frowning, right? The other possibility is that it might look like this. Of course, this is when a is positive. So it's not possible that a is 0, because we already said we're talking about situation when a is not 0. So there's only two possibilities: a is negative or a is positive. Three. Every quadratic equation a times x squared plus bx plus c equal to 0 with a non-zero a. So every conceivable quadratic equation can be solved with the quadratic formula. So that's one of the things that you're required to memorize. Here, we'll copy it again. So x is negative b subtract square root b squared minus 4ac over 2a. That's one of the solutions to that quadratic equation. What's the other one? Right, exactly the same thing, except now you need to make that that subtract an add. So, or x equal to negative b add square root b squared minus 4ac. Over 2a. And as a reminder, I'm perfectly aware that there is a mathematical symbol plus or minus. I am aware of its existence, but we're not going to use it in this class, which is to say that if you use it, your answer is wrong. I promise I have perfectly good reasons for making that restriction. Good. Every quadratic equation can be done like that. 4. The thing in the radical, that expression in the radical, is significant enough to have its own name. What's its name? Discriminant. So the discriminant d equal to b squared minus 4ac tells you how many solutions there are. Specifically, how many real solutions there are. And they correspond to the following 3 pictures. So 1, 2, 3. So suppose that in each case this horizontal axis is the x-axis. So in the first case I'll draw a parabola that opens up. I'm going to make all of them open up. Because now the thing that I'm going to ask is, concerning this specific parabola, how many x-intercepts does it have?
0.
None, right? 0. So the number of x-intercepts is 0, which is to say that the number of real solutions is 0. Okay, now imagine that I grab that parabola and I can move it around. I'll grab it and pull it down to where it's just sitting on top of that axis. Touching the axis in exactly one spot. Now how many x-intercepts are there? 1. And how many real solutions? 1. Okay, then if I grab that parabola and I pull it down any further at all, then this single intercept will split into 2 separate intercepts. So in this case, the number of x-intercepts is 2, and the number of real solutions is 2. Now, these 3 pictures are under the item where we're talking about the discriminant. So what does the discriminant have to do with these three cases? Well, let's imagine for a second. Suppose the discriminant turned out to be negative 25. That's conceivable. The discriminant is the thing that's in the radical. What if we were trying to put negative 25 into the radical? Can you do that? No, you can't. There's no real result for that. So notice that in both cases, we need to compute the square root of the discriminant. So if the discriminant is negative, that means we wouldn't be able to do either one of those. Which one of these has no real solutions? That one, right? So this is the case when the discriminant is negative. Okay. Well, all right. What if the discriminant, what if it was 100? That's conceivable. In the two solutions, we'd want to compute the square root of 100, which is 10. Right. So then this solution would be negative b subtract 10 over 2a, and this one would be negative b add 10 over 2a. So one of them, if the discriminant was 100, we'd compute the square root of 100. That's 10. Negative b subtract 10 over 2a. Negative b plus 10 over 2a. That'd be two different values. Because one of them we'd be subtracting 10, and the other one would be adding 10. Which one of these has 2? The one on the right. Okay, so there's only one possibility left, right? So what's this one? This is when the discriminant is 0. So let's make sure that we understand visually how that relates to the algebra. So, well, in both cases, when you're computing the solutions, if the discriminant is 0, well, what's the square root of 0? It'd be 0, right? So this solution would be negative b subtract 0 divide by 2a. And that one would be negative b add 0 divide by 2a. Well, subtracting 0 and adding 0, that's the same as doing nothing. So there'd just be one solution, negative b over 2a. Okay, any question about these things? This is what we talked about last time. Okay, so now we'll use these things and one more new thing. Here's the main idea for today. Let y be equal to ax squared plus bx plus c with a not 0. The following are equivalent. Okay, so the first thing could be something that, well, the plot of y equal to ax squared plus bx plus c has an x-intercept of m0. So maybe something like this. So you take that quadratic, you plot it, and you observe that, oh, look, it's got an x-intercept there at m0. That could happen. But if that happens, then something else must also happen. Is that if you plug x equal to m into ax squared plus bx plus c. If you plug in m, what do you get? Well, on the one hand, you'd get am squared plus bm plus c, right? Of course. But I claim that you can tell me exactly the numerical value. You get 0. Because look at what this picture is saying. When the x value is m, what's the y value? 0. So if you plug x equal to m into that, out will come a 0. And 3. This is what ties them all together with a neat bow. And that is when you factor ax squared plus bx plus c, x minus m will be a factor. Okay. So let's start out with an easy one. Really, this is just a remark. So we could say, consider let y equal x squared plus 10x minus, what do I want? 12. No, not 12. Come on, brain. Two things, 12 and negative 2. So negative 24. My brain was all cramped up for a second there from the break, I guess. Okay, so in the first place, does this factor? Yeah, right? Notice that y is equal to x minus 2 multiplied by x plus 12. Okay, lovely. If we were to plot this, quadratic, it would be a parabola. Would it open down or up? It would open up. Why would it open up? Right. The leading coefficient is 1, which is positive, so it's going to be a parabola that opens up, one that would hold water. Furthermore, because of this remark, because of the remark we just made, it would look like the following. So concerning this expression, what would you get in the right-hand side if you plugged in x equal to 2? You get 0, right? Because you'd have 2 minus 2. That would be 0, and it's just not relevant what the other one is, because you're going to multiply it by 0. It's 14, but it doesn't, I mean, who cares, right? It's 0 multiplied by 14. What's something else you could plug in to get 0? Negative 12. So, as a result, we know that there's got to be a point here-ish, and another point here-ish, that the parabola has to go through when you plot it. Now, what are the coordinates of those points?
2, 0, negative 12.
Right. 2, 0, and negative 12, 0. And the parabola would look like this, more or less. if I if I could draw nice. So that's what this remark is saying. It's saying that, well, if you can factor a quadratic, you can say a great deal about it. Okay. Now here's where the fun begins. Please factor x squared plus 5x minus 8. Okay, so we did exercises more or less just like this. They looked just like this at the beginning of the semester. And the way that we dealt with it is we did the product sum thing. We said, well, and now I'm going to start referring that referring to it as the easy way. Can we do it the easy way? Which is to say, can we find two numbers whose product is what? -8, and whose sum is what? 5. So can you think of two numbers that'll do it? Probably not off the top of your head unless you're very quick. There aren't any integers that do it anyway. Okay. Well, this is an expression, and we want to factor that expression. And we can't do it using the techniques that we already know. But using the remark on the previous page, we know that the factors, whatever they are, have to be in correspondence to solutions to an equation. So what we're going to do instead is we're going to solve an equation. So specifically, what we're doing, sort of, in your imagination, for those who, that helps. What's happening is that you can imagine that we're plotting y equal to that. We're plotting y equal to x squared plus 5x minus 8. What's the equation of the x-axis? Y equals 0. So we want to know when the red is touching the graphite. So specifically what we're going to solve is we're going to solve x squared plus 5x minus 8. Well, that's y, but y is 0. So this. So you don't need to write this to answer the question, this picture. I'm just making sure that you understand how these things are related. Okay. So again, our technique to solve a quadratic equation, at least before, was can you factor it? Can you factor it easily? You cannot. Which means that now we're going to use the big gun, right? The big machine, if you like. What are we going to use? We could do that. We could do that, complete the square, but I'm just going to use the quadratic formula because it makes all of the thing uniform. So I'll solve this with the quadratic formula. In order to use the quadratic formula, we need to identify the coefficients a, b, and c. So on this specific exercise, what are the coefficients? 1, 5, and -8. Very good. Okay, so now it's just a matter of writing it out. Okay, so then that'd be -5 subtract square root of discriminant. So 5 squared minus 4 times 1 times -8 over 2 times 1. That's one of the possibilities. The other possibility would be instead of subtracting the square root of the discriminant, we'll add it. So x is -5 plus the square root of the discriminant. I don't want to write b. So 5 squared minus 4 times 1 times negative 8 over 2 times 1. So that discriminant, that's just calculator stuff there. Okay, so 5 squared minus, good, 57. So x would be negative 5 subtract square root 57 over 2. That's one possibility. The other possibility is that x is negative 5 plus the square root of 57 over 2. Okay. So, is this the answer to the question?
No, we could use those as two anti-parentheses factors.
Very good. That's exactly what we're going to do. So what I want you to observe, what this is saying, is that look at this crazy number. Negative 5 minus the square root of 57 over 2. Well, it's a number. What would you get if you plugged it into that? You'd get 0. After a bunch of crazy arithmetic and simplifying radicals and all kinds of stuff, you'd get 0. What would you get if you plugged this one into that? You'd get 0. Okay, so the previous remark and discussion is telling us that zeros are in correspondence to factors. So what if x equal to 5? It's not, but what if x equal to 5 were a 0? Then what would be a factor? X minus 5. What if x equal 8 was a 0? X minus 8 would be a factor. These are the zeros. So that's telling us that x squared plus 5x minus 8 has to factor in the following way. X minus something goes there, multiplied by x minus something goes there. What goes in the slots? Those things go in the slots. It doesn't matter which one goes where, because multiplication commutes. Negative 5 subtract square root 57 over 2. Negative 5 add square root 57 over 2. So at the top, when we asked ourselves, can we do it the easy way? Can you find two numbers whose product is negative 8 and whose sum is 5? Probably not, but these are the numbers, right? That's what I meant, unless you're real quick on your feet. One of them is negative 5 minus the square root of 57 over 2, and the other one is negative 5 plus the square root of 57 over 2. Obviously. Furthermore, if we were to draw a picture of this now, so in the first place, if we were to plot this, would the parabola open down or up? It would open up, and why? Because the leading coefficient is 1. Okay. Furthermore, because there's, you can see that there's two different solutions. The discriminant is positive. That means that it should look like this if you were to plot it. And you can do even one better than this. You can actually tell me the coordinates of those two green points. What are their coordinates? All right. This one is negative 5 plus the square root of 57 over 2, comma 0. There's an x-intercept right there. And this one is the other one, right? So that'd be -5, subtract the square root of the discriminant over 2, comma 0. Beautiful. Any question about this example? So the point is that the solutions are in correspondence to the factors, which are in correspondence to the x-intercepts. Solutions, factors, x-intercepts. Let's do another one. So anytime we do a thing with polynomials, I always open with a monic example, but we always have to follow that up with a non-monic example because non-monicness makes the, makes things more interesting. So here we go. Please solve 3w squared minus 4w minus 9. Okay. So again, we have a technique to solve this from previous work in the semester. In this case, the request would be, can you find two numbers whose product is what? What product would we be looking for? -27, because we'd want it to be 3 multiplied by -9, which is -27. And what would we want the sum to be? -4. Well, how about it? Can you think of two numbers that'll do it? Nah, not among the integers anyway. But the quadratic formula will tell us what numbers will do it. Okay, so then let's first solve an equation. So we're going to take that expression, 3w squared minus 4w minus 9, and we're going to say, okay, let's set that equal to 0 and solve. And we'll do it with the quadratic formula. So A, B, and C are 3, -4, and -9. Now it's just a matter of very tediously writing all this down. Okay, so W could be -4, subtract the square root of -4 squared minus 4 times 3 times 9, -9. Over 2 times 3. That's one possibility. The other possibility is that W could be -4 plus the square root of the discriminant. Over 2a. Okay, so the discriminant, that's calculator work. 124. So W could be 4 minus the square root of 124 over 6, or could be W is 4 plus the square root of 124 over 6. Yes?
I put that into my calculator. -4 squared
Mm-hmm.
minus 4 times 3 times -9.
Mm-hmm.
I got 92.
That is because when you typed it, you typed this into your calculator. Negative 4 squared, which your calculator interprets to mean negative 1 multiplied by 4 squared. So in the order of operations, which occurs first? This one occurs first. So when you do this, this is negative 16. But in fact, you meant negative 4 squared. Other questions? Okay, so these are the solutions. Is this the answer to the question? No, right? This is not the answer, because the request was to factor. But we do know that solutions are in correspondence to the factors, right? Which is great. So we know that 3w squared minus 4w minus 9 should factor in the following way. We should have w minus something goes in this slot multiplied by w minus something goes in this slot. So what goes in the slots? Right, these solutions go in there. So I'll dutifully copy them in there. But in fact, okay, this is actually not right, at least not yet. So remember, the previous example was we did a monic example, and this example is a non-monic example. But here's the thing, when we derive the quadratic formula, in a sense, we paid the non-monic price once and for all to get the quadratic formula. So the quadratic formula is kind of blind to whether to the leading coefficient. It can't see it in a certain in a sense, which means that the issue of monicness, non-monicness, hasn't come up yet. But now it's come up. This factorization is not right. Right. So let's consider. If you were to multiply this out and collect like terms with FOIL, right? You could do it, right? In principle, the algebra, the arithmetic would just be, it would be terrible. But you could do it. You could find the F term, the O term, the I term, the L term. You could find them all and simplify it. Notice that only the F term would have W squared, right? The O and the I term would just have W, and the L term wouldn't have any W at all. Only the F term would have W. At the present time, the way that it's written, what would the F term be? It'd be 1 W squared, because it would be W times W. So if we were to multiply this out right now, it'd be 1 W squared. But how many W squareds do we need? 3. Well, the fix for this is easy enough. You just take this and just copy it over here. Now it's right. Kind of a small price, isn't it? It is a price, right? You have to understand that this is the price of it being non-monic. I claim also that it occurred on the previous exercise when it was monic, because, well, after all, I can say that, yeah, what's the leading coefficient there? 1. So I took that 1 and I copied it and put it right there. See that 1? Sitting there. Good. Any question about this example? Yes?
I have a question. Is it always going to be in the parentheses W or X minus times W or X minus something?
Yes. Because solutions are in correspondence to factors. If this was an 8, it'd be w minus 8. If it was a negative 10, it'd be w minus negative 10. If it was a giraffe, w minus giraffe.
Now,
Whatever goes in there.
I'm sorry to interrupt you. What if the solution, what if the original formula was, those were pluses
What were pluses?
in the original quadratic equation?
This?
No, to the left. In
This?
that equation, what if those were both pluses? Would that change the negative signs
No.
in the factor?
No, it wouldn't. It's always going to be w minus something that goes in there. W minus something that goes in there. It's always that way.
Okay, but when we did it in the past,
Mhm.
those signs were dependent upon the sign
I see.
in the
I
equation, right?
I see what your question is. So, x squared plus 10x, this is the example from 2 pages ago, minus 24. This factors as x, we said what? Plus 12 minus 2?
Correct.
Okay, but just a second. It can just as well be written in this way. So, in the first place, for this factor, this one, what would you need to plug in so that it would be 0?
Positive. Oh, two.
2. For this factor, what would you need to plug in so that it would be 0? So it is always of the shape x minus one solution multiplied by x minus the other solution. But, you know, if you felt so inclined, you could, you know, obviously x minus negative 12 is x plus 12. But it will always be this way. Good. So, for example, please solve z squared plus 2z plus 13. So, because I'm up against the clock, we're going to go through this one quickly. Now, this one has a twist, a little bit of a twist. So, in the first place, can you do it the easy way? No, you can't. Yes? Uh-huh. No. Because I thought, you know, I couldn't even remember what was going on before the break. So I thought, there's no way that they're going to remember anything either. So we'll do it on probably Wednesday or Friday. I'll send an email. But back to this. We're going to solve an equation. No, I don't want you to solve this. That's not the request. Sorry. The request is to factor this. Sorry, I'm rushing and now my brain is not clear. So we're going to solve z squared plus 2z plus 13 equal to 0, and we'll do it with the quadratic formula. But even before that, I can say, well, what's the discriminant here? It's the thing that goes in the radical, right? So 2 squared minus 4 times 1 times 13. That's negative 48. So what we'd be saying is we're planning on putting negative 48 into the radical. Is that permissible? No. Negative discriminant. Therefore, D is negative, and there are no real solutions. Wait a second. So we were requested to factor this, and we said, okay, fine, I'll solve an equation. But then we've just said, actually, there aren't any solutions. So the answer to the question is, the correct response to this request is that z squared plus 2z plus 13 is prime. So you've used the word prime before, but not in the context of polynomials. So this is the first time you're using it. To be clear, in third grade or in Miss Harris's class, you might have been asked something like, please factor 35. Well, the response is that it's 5 times 7, right? But if you were requested to factor 23, then what's the correct response? 23 is prime. It doesn't have any integer factors. So polynomials can be prime. Okay. Finally. So if now the request is factor z squared plus 2z plus 13, so that's the exact same polynomial as up there. Now if I stop writing, then it would be exactly the same exercise. We couldn't proceed with a negative discriminant, because remember that the rule in this class is that all variables are real unless explicitly said to be complex. So let's factor this in the complex numbers now. So that means that it doesn't matter what the discriminant is, we're always going to be able to proceed. Okay. So we're going to solve z squared plus 2z plus 13 equal to 0 with the quadratic formula. So one of the possibilities is that z is negative 2 subtract the square root of the discriminant, but notice that we wrote the discriminant up there, and I'm trying to hurry through this because I'm against the clock. So this would be over 2 like that, or negative 2 add the square root of the discriminant over 2. Oh, we've got negatives in the radical. Is that okay? Yeah, because we're in the complex numbers. So this negative can come out as what? As an I. So this would be negative 2 subtract square root 48 multiply by I over 2, or z is negative 2 plus the square root of 48 multiply by I over 2, and therefore we can finally write the answer. Z squared plus 2z plus 13 factors as z minus, here's one slot, multiplied by z minus second slot. What goes in the slots? Those solutions. And finally, while I'm copying this down, this is an illustration of why mathematicians like the complex numbers. The reason is because polynomials, it's possible for them to be prime when you're dealing with the reals. But when you're dealing with the complex numbers, no polynomial is prime. All of them can be factored, like so. Okay, welcome back to the campus.